All right, here's the last day of 6.1. So the difference between what we're going to do today and what we've been doing is that here I give you a data set, and we have to find the standard deviation, and we have to find the mean. If we know those two things, we can make a confidence interval. I'm also going to show you a new way to do it using your calculator. So normally you go second distribution, we do our invert norm trick, right? But now there's actually an easier way to do it. You go stat over to test, and then you go down to number 7 where it says z interval, right? So there's two types of tests for means. There's something called a z-test and something called a t-test. We're going to use the z because we're talking about z-scores. We're going to talk about t-scores next week. Okay, so apple trees produce an apple yield that is normally distributed. So that's important. If it's not normally distributed, I'm going to need this number to be a lot bigger, right? So if it's not normally distributed, then I would need a lot more data in order to do this. But since it's normally distributed, that's fine. I can have, here I have 10 pieces of data, and that's okay. They also give you the standard deviation of 16.6. So if you make your curve here, right, you want to construct a 90% confidence interval, right? So you're going to have some things in the tails, right? And basically what we're trying to do is we have a sample of these different trees producing this many apples, right? Every tree produces that many apples. What we're going to do is try to find a good range that we think the population mean is going to be in, right? So this is a sample mean. We're going to look at the population mean. So the thing that goes in the middle is going to be our mean. And the standard deviation, I already know is going to be 16.6 divided by the square root of, I have 10 things. So what I need to do is I need to find the mean. So you can do that a couple different ways. You can just add these together, then divide by 10, or what you can do is you can go stat, edit, and I entered all my stuff into list 1, right? So here's all my data in list 1. Then I go second quit, and then when I go stat, calculate one variable statistics, it gives me an x bar of 217, and it gives me actually the standard deviations as well. So it gives me s sub x, and it gives me the standard deviation of x. So sx is 17.499, and standard deviation is going to be 16.6, right? So the one that we want to use here is this. This is the population standard deviation versus this is the sample standard deviation. If you can use the population standard deviation, always go with that one. That's going to be the closest to the actual standard deviation. Okay? So now what you can do is you can just go through in your calculator and you can do your second distribution, your invert norm stuff, right? But I'm actually going to show you another way to do it real quick. So hit stat, then go over to calculate. Or sorry, go over to test. So stat, over to test. And then you're going to do number 7, z interval. So it's going to say, what do you want? Do you want to have data or do you want to have stat? So if you have stat, you're just going to be entering in the things, the numbers manually. If you go data, right, that will use your list 1 as your input. Frequency should always be 1. We'll do this one, we'll do it with stat. Why not? So here it's asking for our standard deviation, so you have to physically type it in, 16.6. It's going to ask for our mean, again, physically type it in, 217, and then it's going to say n, what is your n, so how many things are in there. We have 10 things, and then what do we want our confidence level to be? So we want a 90% confidence interval, right? And then it will create that confidence interval for us, so 208.37 and 225.63. So that means we're 90% confident that the true mean of apple trees, or the true mean of apple yield in this orchard, is between 208.3 apples and 225.6 apples, right? So that's a lot easier than what we were doing before, where we had to do our invert norm and all that good stuff, right? So let's go ahead and let's do our second example here. So our second example, notice it's the same thing. things that are important. It's normally distributed. Again, I would need a lot more data. I would need at least 30 pieces of data in order for this not to matter, the distribution not to matter. So I need the original distribution to be normally distributed, and we're going to construct a 95% confidence interval. Okay, so 95%, this confidence interval is going to be a little bit wider. The other thing that's kind of weird is that I gave you this thing right here. So this is called a stem and leaf plot. And with your stem and leaf plot, 320 means 320 apples, right? So I went through and I entered in all of my data, stat, let's see here, stat edit. I entered all my data into list 2, right? So you could either enter it into list 2 right now. I also shared a printout with you if you want to check that out, where it's easier to read. But basically, I kind of want the same thing. I want to figure out what the mean is. I want to figure out what the standard deviation is, and then that will get me what I need. So let's go here. You can do this. Actually, you need to do this. You need to do one variable statistics, but we don't want to do it with list 1 anymore. We want to do it with list 2. So I hit second 2. Frequency, just leave blank. Right, so we get x bar to be 343.3 repeating. And we get our standard deviation. Remember, don't use 13.3, don't use SX, use sigma x, the population standard deviation of 12.898. And then we're doing sample means, so we just divide by the square root of, it should tell me n here. N is 15, so divide by the square root of 15. And we want to make a 95% confidence interval now. Okay, cool. So go stat. And then we're going to go over to test, right? This is our new way of doing it. We're going to always use number 7 for right now, our z interval, right? And now let's use data, right, instead of stats. So we're going to use data. Notice this is my old standard deviation. So we have to type in our new standard deviation, 12.898. Now, don't worry about dividing by the square root of 15 because your calculator in the program will already do that for you when you calculate the confidence interval. Notice we want our list that we use to be list 2, not list 1. So I hit second 2. Unless you have list 1, then I hit second 1, right? But I entered mine into list 2. And we want 0.95. We want a 95% confidence interval. Very simple. So that's going to give me 336.81 to 349.86. So I'm 95% confident that the true population mean of this orchard is between 336 apples and 349 apples. Okay, cool. Let me know if you have any questions. Peace.